Hello everyone, welcome to Vyas Certification. In this session we are going to discuss NCERT and exercise solutions of chapter number 10 mechanical properties of fluids. Clear? So in this session you will find detailed solution of each and every question, as well as you will find the theory behind that question also. It means overall you will understand the whole concept of this chapter through the questions. Clear? So now we are going to discuss each and every question. So concentrate on a screen. Let's start. Now dear student, we are going to discuss question number 10.1, and in this question we have three parts of this question, part number A, B and C, and in this question it is given to you explain why. Number 1, the blood pressure in human is greater at the feet than at the brain. Clear? So my dear student, this is actually logical question. Now actually we know the blood pressure, or if we talk about gauge pressure is actually given by so if we talk about gauge pressure is given by P equal to rho GH. Clear to everyone? Now we can say as the height of a column, as the height of a liquid column increases, we can say pressure increases. Clear to everyone? So now we can say the blood pressure in human is greater at the feet. Why? Because we know if we talk about the column of a blood from the feet, we can say the height of a blood column that is more compared to height of a blood column at brain. Clear? So now we can say because value of H is more in at the feet. Value of H is more at feet, so we can say pressure is more at feet compared to brain. Clear to everyone? So in short I can say because height of a blood column is more at the feet compared to brain, that's why we can say pressure in human is greater at feet compared to brain. Clear to everyone? Now we are going to discuss part number B. Clear? So in part number B it is given to you atmospheric pressure at a height of about 6 km decreases to nearly half of its value than sea level, though the height of atmosphere is more than 100 km. Now listen carefully. Actually we know as we move away from a surface of a earth, or we can say as we move from the surface of a earth to a certain height, definitely density of a air decreases. Clear? But actually the density decreases not in a uniform form. Generally it is seen that density is varies like the e to the power minus times ky. Clear? So we can say if we draw here a graph between y and density, then we can say it should be like this. Clear? Or we can say this is exponential decreasing curve. Clear? We can say this is exponential decreasing curve. It means we can say initially density of this air decreases more compared to after some time. Clear? So we can say if we are talking about initial increase in length, if we are talking about the height of 6 km, so height of 6 km from the surface of earth, the density decreases up to half. Clear? But because we know height of an atmospheric column we are taking approximately equal to 100 km, so rest half of a density decreases from 6 km to 100 km. Clear? So answer is very simple here, because the variation of a density in our atmosphere is not uniform. As we move away from a surface of a earth, the density decreases, we know very well, but initially density decreases, the decrement of a density is more in initial heights compared to later one. Clear? So now we can say that from 0 to 6 km density decreases to half, and the rest half of the density it is decreases after 6 km to 100 km. Clear? So this is all about part number B. Clear everyone? Yes. Now we can say if I am talking about part number C, hydrostatic pressure is a scalar quantity even though pressure is a force divided by per unit area. Now listen carefully. Actually we know, let's suppose if I draw here one diagram, let's suppose this is a container, and in this container let's suppose we have a liquid up to this level. Clear? Let's suppose I have liquid up to this level. Clear to you? Now let's suppose if I am saying here we have a ball, let's suppose this is a cricket ball. Clear? Now we can say because this is inside this liquid, so definitely we can say according to Pascal law, forces that is exerted perpendicular to this surface like this. Clear? And now we know this force is exerted per unit area, that is known as pressure. Clear? So now we know that pressure is equal to force per unit area. Clear? Now if I am talking about this small areas, clear, and you know force is a vector quantity, it means the pressure should be a vector quantity, but it's not. Why? Because we know in a pressure we have a magnitude. Definitely, let's suppose we are getting value 2 Newton per meter square, then we can say definitely it has some magnitude. Yes. If we are talking about unit, definitely it also have some unit. Yes. But what about direction? Clear? So now we can say if we are talking about hydrostatic pressure does not have any specified direction. Clear? Actually we can say the direction of a force is actually from all the sides on this ball. Clear? It means we can say we do not have any specified direction. That's why we can say although pressure is having direction, but that direction is not a certain or unified or a particular direction. Clear? So we can say we cannot put this pressure, hydrostatic pressure, in a vector quantity. So we are putting this physical quantity in scalar quantity. Clear to everyone? So this is all about this question. Clear?